Good morning, everyone. This is the session number 1 from the chapter of wave optics, and today I will be giving a brief description on the development of wave theory of light. So I have written here 4 bullet points, and these are some of the major developments which happened with regards to the development of wave theory of light. So in 1637, Descartes proposed the corpuscular model of light. That is, he proposed that this is the medium 1 and this is the medium 2. So he proposed that if a ray of light bends towards the normal upon refraction, if a ray of light bends towards this normal upon refraction, this is the interface between the medium and the medium 1 and the medium 2. This line which I have drawn here, it is the interface between the medium 1 and the medium 2. So as per the corpuscular model of light proposed by Descartes, it states that the ray of light, if it bends towards the normal upon refraction, then the speed of the light in the second medium, that is in the medium number 2, will be greater than the speed of the light in the medium 1. So this was the corpuscular model of light as proposed by Descartes. However, in 1678, the Dutch physicist Mr. Christian Huygens, he put forward the wave theory of light, and he said that if a ray of light is refracted into the second medium, and upon refraction, if the ray of light is bending towards the normal, as in this case, it is bending towards the normal, then the speed of the light in the second medium will be lesser than the speed of the light in the medium 1. That is, the speed of the light in the medium 2 will be less in comparison to the speed of the light in the medium 1. So the wave theory of light, as proposed by Mr. Christian Huygens, was totally the opposite, or it was contradicting this corpuscular model of light as proposed by Descartes. Descartes proposed that upon refraction, if the ray of light is bending towards the normal, then the speed of the light in the second medium will be greater than the speed of the light in the medium 1. However, as per the wave theory of light proposed by Mr. Christian Huygens, the ray of light upon refraction, if it bends towards the normal, then the speed of the light in the second medium will be lesser in comparison to the speed of the light in the first medium. So both these theories were totally opposite to each other, and or you can say that this wave theory of light proposed by Christian Huygens was in contradiction to the corpuscular model of light as proposed by Descartes. Now here there was one more important a major difficulty which was faced during this period of time, that the wave theory was not readily accepted, because it was felt that the wave requires a medium for the propagation of from requires a medium for the propagation from one point to the another point. Now, since light was able to travel in vacuum, so means it was difficult to accept this theory that light is a wave during this period. So, but in 1801, that is in 1801, Thomas Young confirmed that light is a wave phenomena by his famous interference experiment. And with the help of this interference experiment, he also calculated the wavelength of the visible light, and it was found to be very, very small. The wavelength of the yellow light is approximately zero point 0.5 micrometer. So in 1801, Thomas, with the help of this interference experiment, confirmed that light is a wave phenomena. But still, the wave theory was not accepted because because it was felt that wave requires a medium for the propagation from one point to another, and since light was able to travel in vacuum, then there was a doubt that how can light be a wave. So, but now this confusion was very well explained by Maxwell in 1855, and he propounded that light is an electromagnetic wave based on the set of equations uh, which he derived for stating the laws of electricity and the laws of magnetism. So he was able to propound that light is an electromagnetic wave by his famous electromagnetic theory of light, in which he developed a set of equations um, for the laws of electricity and for the laws of magnetism, and using those set of equations, he was able to derive the wave equation, and with the help of that wave equation, he calculated the speed of the electromagnetic wave in the free space. So what he found that the speed of the electromagnetic wave in the free space was almost equal to the speed of the light. So based on that, on this fact, Maxwell propounded that light must be an electromagnetic wave, and he also confirmed that electromagnetic waves are um, are due to the changing electric and the magnetic field, and the changing electric and magnetic field gives rise to the electromagnetic waves, or you can say the light waves, which can travel even in the vacuum. So these were the this was a short description on how the wave theory of light was developed. So in 1855, Maxwell, with the help of his famous electromagnetic theory of light, confirmed that light is an electromagnetic wave, and electromagnetic wave is a phenomena due to the changing electric field and the magnetic field, and the changing electric field and the magnetic field, or you can say the changing electric field and the magnetic field gives rise to these electromagnetic waves, or you can say the light wave, which can even travel in the vacuum. So these are the this is a short description of the development of the wave theory of light. In the next session, that is in the session, not in the next session, means in the coming sessions, we will be discussing about the Huygens principle, and we will be deriving the laws of refraction and reflection. That is, I will be just writing it here, that what are the topics which we will be covering in this chapter. The first point, or you can say the first topic which I will be covering in the forthcoming sessions, will be the Huygens principle, and we will be deriving the laws of reflection and refraction. We will discuss about the phenomena of interference, pheno- phenomenon of interference based on the principle of superposition. Third, we will be discussing the phenomena of diffraction. Phenomena of diffraction based on the Huygens Fresnel principle. And lastly, we will be discussing the phenomena of polarization. Considering that light is a transverse electromagnetic wave. So these are the four important topics which we will be covering in the forthcoming sessions. So in this session, I just wanted to give a brief description about the development of the wave theory of light. And so from session number 2, in the session number 2, I will be taking up the Huygens principle, and we will be deriving the uh, laws of refraction and reflection. So thank you very much for this session, for joining this session, and I hope you have understood what I have tried to discuss here. And in the next session, I will be coming up with the Huygens principle. So till then, have a nice day. Bye.